here is the quotient rule, okay? And so here I have a quotient of two functions, f divided by g, and I want to take the derivative. So basically this rule is telling us that in order to compute the derivative of a quotient, we take the bottom function and we multiply it by the derivative of the top function, and then we subtract the top function multiplied by the derivative of the bottom function. And this whole quantity gets divided by the bottom function squared. So that is called the quotient rule. And just as a warning, try to remember that the derivative of a quotient is never going to be equal to the quotient of the derivatives. Okay, so this is not true. Instead, we have the quotient rule up here. Okay, so one other quick thing I want to say about the quotient rule is that you can write it in a couple different ways. It's not as flexible as the product rule because there's subtraction here and we've got a quotient. However, you can reverse the order of these if you want to, and that's pretty much all you can do. So I could write this like with the numerator like this if I wanted to. Another thing I want to point out is, there are all these ways people try to remember the quotient rule. I usually just remember that there's subtraction, and the function that you're going to differentiate first is the top function, and then I just sort of remember the basic shape. But there are all these other ways. For instance, you'll see people write it as high over low. High is for F, low is for G, and then they're able to remember these little songs like low D high minus high D low over the square of what's below. Or some people use this low D high minus high D low, low, low. And, I just can never remember either of these. And it's just, for me, it's, easier to just remember the rule. But, whatever works for you. Okay, so let's do this example. So here I have find dy dx. So that's the derivative of y with respect to x if y is equal to 2 divided by x cubed minus 1. So that's clearly a quotient. So let's apply the quotient rule. So in this case, I'm going to be thinking of my function f as the top function. So this is my function f, and then this is my function g down here. So let's calculate dy dx, or I'm just going to write y prime there. So remember, it tells me to start off with the bottom function. So I have x cubed minus 1, and I'm going to be multiplying that by the derivative of the top function. So that's 2, and then I take the derivative. The key thing to remember is subtraction. So with the product rule, addition. With the quotient rule, subtraction. Next, I'm going to be taking the function f, which is just 2, and I'm going to be multiplying it by the derivative of g, which is x cubed minus 1 prime. And then that whole thing, so don't forget the denominator, that whole thing is going to be divided by the bottom function squared. So in this case, that's going to be this guy, so x cubed minus 1 squared. And so let's finish this off. So this gives me x cubed minus 1 times 0, because 2 is just a constant, times minus, so remember, subtract for the quotient rule, and the derivative of this guy is just 3x squared minus 0. And nothing really happens. No differentiation is occurring in the denominator. So let's just clean this up a bit. That whole term is going to be 0, and I'm left with a negative 6x squared in the numerator. I'm just going to bring the negative out front. And then x cubed minus 1 squared in the denominator, and we're done. That is our derivative. Let's do one more example using the quotient rule. So I want to differentiate h of x here. And I'm going to think of this as my function f, and then this is my function g in the bottom. So in this case, let's write h prime of x. So remember, I'm going to first write my bottom function, which is 7x cubed plus 10. And I'm going to be multiplying that by the derivative of the top function. So that's 3e to the x minus 5. And I'm subtracting, because it's the quotient rule, and then I'm going to be writing the top function, which is 3e to the x minus 5. And I'm going to be multiplying by the derivative of the bottom function. So 7x cubed plus 10 prime. And then this will be divided by the bottom function squared. So 7x cubed plus 10 squared. So let's go and actually calculate the derivatives now. So I have 7x cubed plus 10 times, and the derivative of this guy is 3e to the x plus 0 or minus 0. Not that it matters, but, and remember that the derivative of 3e to the x is 3e to the x. I'm using the constant multiple rule, and I'm also using the fact that the derivative of e to the x is itself. Okay, so then I subtract, and we have 3e to the x minus 5, and the derivative of this function is 21x squared, again, plus 0 because 10 is a constant, and the denominator stays the same. Okay, so I am just gonna clean this up a little bit. So this is just 0. So I'm gonna distribute this, and like I said, you're done at this step. You've computed the derivative, that's done. But I'm just gonna clean it up a little bit and distribute. So it looks like I have 21 e to the x cubed plus 30 e to the x. Over here, I'm going to have minus 63 x squared e to the x, and then minus subtracting and subtracting, that's going to give me a positive here. So I'm like distributing the negative, and I have 105 x squared, and denominator is still the same. And I don't think there's anything I can simplify here.